Okay, so for this first one, it was just a regurgitation of formulas. You should have used your triangle. Remember that speed is the same thing as far as velocity, velocity. The only difference is that velocity includes direction. So speed and velocity will have the same exact number. Velocity would just include a direction. You did not have to include an example of 10. I just did that to help you. For the speed of the sleigh, use the same formula, distance divided by time, 326 divided by 22. You should have something like this. So it goes in one time, giving you 10, bring down the 6, goes in 4 times, gives you 18, bring down your 0, leaving you with 40, going in 1 time, bringing down the 0 again, and that will continue. So you could say it was 14.818 or 14.82 feet per second. Okay? And you did have to make sure that this was either 14.82 or 14.818. You cannot have 14.81. That would be incorrect. That would not be rounded properly. And unfortunately, remember, you cannot use a calculator. That is a decision that is out of our control, and you have to remember that you have to know how to divide, okay? Find the speed of a football flying 63 yards in 3 seconds. So you have your distance here and your time here. Okay, again, we're going to be nice, and you did not have to convert. If you did convert, you'll get credit for that question in feet. But you have 63 divided by 3. Pretty simple math here. Put 3 into 63, and you should get 21, which is 21 yards per second. The velocity of a jet traveling from Dallas, Texas to Chicago, Illinois in 4 hours. So you have to know a little bit of geography. Texas is in the south, Illinois is in the north, okay? So you're going to be going basically north, okay? Your time here is 4 hours. Your distance is 968 miles. So use the same formula. 968 divided by 4. So you put 4 and 968. You should get 242 miles per hour. Okay? Find the velocity of crow, which flies, it should say a crow, which flies the 2677 miles from Seattle, Washington to Atlanta, Georgia in 20 hours and 3 minutes. Give the answer in miles per minute. Okay, so there's your time, there's your distance, right? You first had to make sure that you have everything in the right format, because it says give it in miles per minute. So we have it in miles, but that's in hours and minutes. So we know that 20 hours times 60 minutes, 2 times 6 is 12 with 2 zeros, is going to give us 1200 minutes, right? If you add 30 to that, it will give you 1230 minutes. So you put your time over here. And you're going to divide. And you know that goes in twice. And that only goes in once. And that goes in 7 times. And that will go in another 6 times. Okay? So you could round that to 2.18 miles per hour. Define acceleration. That is a change in speed. The formula for acceleration in the acceleration formula, the starting speed of something is represented as, you could say starting velocity, or you could also say initial velocity. The I over here means initial. A negative acceleration indicates that it's slowing down or decelerating. An object changes speed from a starting speed of 25 miles an hour to any speed of 15 miles an hour in 8 seconds. Find its acceleration. So it ended at 15, so that's its final. And you should get, sorry I ran out of room guys, but you should get 1.25, okay? 2 times 8 is 16. That gives you a remainder of 40. 8 times 5 is 40, okay? And it is negative because it's slowed down. So it went from 25 to 15. If the negative numbers kind of intimidate you a little bit, just know that if it slows down, a negative number will give you what you need, okay? Okay, I just realized there's a mistake on this. If you didn't convert, that's okay. We're probably going to have to throw this one out because this says miles per hour and this says seconds. So that should have said meters per second. Okay, because that would have been way too much for you guys to convert. So if you did convert that, you were doing it correct, but we'll have to look at your test and see how you guys did on that, okay? But if you got this much done and you got this, that shows that you understood how to work the problem without converting, okay? That was quite a bit of conversion, so I apologize if you worked that out. Okay, a mallard clumsily comes to a halt on the water from a flying speed of 4.5 meters per second in 12 seconds. Okay, the halt is 0. That's its final velocity, right? So you had 0 minus 4.5 divided by 12. So negative 4.5 divided by 12. That should go in 3 times. Giving you 0.375 meters per second squared. Okay, acceleration of a truck that slows from 80 to 25 in 4 seconds. So you have same formula. Velocity final minus velocity initial gives you 25 minus 80 divided by 4. You have 55 divided by 4. Should give you 13.75 meters per second squared. Okay. An acceleration of 25 meters per second squared means to a third grader, so basically you just had to explain what acceleration meant in a very simple format. So that means that each second the speed increased 25 meters per second, meaning 25 meters per second. Okay? Lots of answers could have been given for that. Okay? Essentially what you needed to explain is that for every second that goes by, it's increasing its speed by 25 meters per second. Okay? A label of kilometers per second squared means the same thing as kilometers per second. That is true. An object that is changing direction is accelerating, straight from the review. An object that is moving at a constant speed is accelerating, false. The net velocity, so you just had to subtract these two because they're going different ways. The arrows were a little confusing. This one should have been bigger, making you realize that it was going this way at 0.2 meters per second. If you did not put the arrow, that's okay, because I wasn't completely clear, but you should have known because it said velocity that you were supposed to include the direction. You're traveling towards Chicago, which is to the northeast, on an Amtrak train at 25.2 meters per second. That's the speed, okay? You're running towards the front of the train at 4.3 meters per second. What is your net velocity? Okay, so you have this and this combined will give you your velocity, and this will also give you the velocity. Okay, so if you're traveling this way, going 25.2, and you're also running towards the front of the train, going 4.3, you would obviously add those numbers. Giving you 29.5 meters per second northeast. What's required to change the direction? An unbalanced force. Which of the following does not represent acceleration? This is straight from the review. A car speeding up does, a car slowing down does, a car changing direction does. So a car traveling at a constant speed means that they're traveling at a constant speed. Doesn't mean they're speeding up. Okay. Examine the graph to the right. It shows the change in velocity, also called acceleration, of a bicycle. According to this graph, what was the bicycle's acceleration between 6 and 10 seconds? Okay, everybody look and make sure that you understand this. Whenever you get a graph, you should always look at these two things first, okay? It's telling you this is a measure of time and velocity compared. In other words, velocity divided by time is going to give you acceleration. We just learned that. Velocity divided by time. That's the formula for acceleration, right? So what you're looking at here is it's speeding up again. It's not speeding up as much. It's not moving here. Speeding up, it's not moving. So if we look between here and here, we realize it's going same speed, same speed, same speed, same speed, same speed. So it's moving, but it's not accelerating. So we say that it's going 0.0 meters per second squared. If I asked you for the speed, you tell me something a little different. You tell me that it was going 6 meters per second or 5.5 meters per second. Okay? Examine the graph to the right. It shows the distance traveled by a vehicle over a certain period of time. So distance over time, meaning it's going to show you its relative speed. Where was it moving with the greatest speed? Steepest one, letter L. Straight from the review. You're on a train that is traveling 30 meters per second north. You decide to move from the front of the train car to the back, and you're walking at a rate of 1. What's your forward velocity? For this one, we're actually going to throw this completely out. Should have said net velocity, in which case, if you were going one way, this was going another, you would have said 29. But it was written a little bit confusing, so we're going to throw that question out. So if you miss that, it will not count against you. Okay? A friend is helping you rearrange your bedroom furniture. You use 25 newtons of force to push the foot into the bed, while your friend uses 20 pulling the head. So you got to make sure you draw this. It says use your drawing to calculate the net force. Anytime they give you a word problem, you always want to draw it so you can visualize it. Don't try to do things in your head. So you have 25 newtons of force being pushed from the back. And you also have 20 newtons of force being pulled from the head. So they're going the same way, so you know to add those. Okay? This one was a great question to see if you guys could just think and analyze a picture. Completely fair question. Wasn't on the review, didn't need to be on the review, because this one shows whether or not you can think and logically rationalize an answer out of a question. So put yourself in this situation. You're on a skateboard, you throw a ball forward, what are you naturally going to do? You're going to go backwards. And you know that from your in-class project and from your reading and your notes that when something goes one way and it reacts another way, it's the third law. Action-reaction law. Very fair question. Everyone should have gotten that right in this class. A child jumps on a trampoline. What's causing the child to rise in the air? Does gravity cause you to rise? No. Reaction force? Yes. Does mass cause you to rise? No, it causes you to stay there. Does inertia cause you to rise? No, it causes you to stay there. Easy. All right. Examine the situation here. Okay. So you have these two people here. You got their mass. Got your acceleration. Okay. This definitely looks like second law. She's going faster. Why? Just because she's stronger? No, that would make him go faster. Her skates experience less friction? No, looks like the same surface to me. She has less mass? Yeah. She's a better skater? Has nothing to do with that. Should say less mass, not weighs less, but still the right answer. A little girl is pulling her sled behind her in the snow. She stops to tie her shoes and the sled kept moving. Stops, sled kept moving. That's all you needed to see right there. Which of Newton's laws? The first law. Objects continue to do what they were doing before, unless acted on by an unbalanced force. As the fuel in the rocket ignites, the force of the gas and explosion pushes out the back of the rocket. Okay, fuel ignites, and the rocket goes upward. Classic case, third law. Some of y'all did that for your project. Mass of a truck, if it produces a 12,000 Newton force while accelerating at a rate of 6. You better have drawn this triangle. Force, acceleration, you're looking for mass. Okay. And that is it. Okay. If you guys have questions, come see me. I will not hunt you down. So, besides those 2 questions that we threw out, every other one was incredibly fair. I feel confident that you guys should have known this. I do realize that maybe they weren't worked out for you, but if you knew the formulas, the book did guide you to be able to plug those in. And again, if you have questions, come see me. Grades get put in at the end of this week. If you need a retest, you're going to have to prove to me that you've been trying and that you legitimately need a retest. And I will absolutely work with you to make sure that you get a retest. Other than that, I think that you guys should be good to go.